SPACEAVOCAT.
SPACEAVOCAT.
Le podcast.
The podcast.
Hello everyone and welcome to this new episode of the SPACEAVOCAT podcast. Today I'm delighted to host Francesca Letizia. Francesca, hello, good morning.
Good morning.
I'm so glad to have you today because we're going to talk about a very specific and very urgent topic in the space industry, which are space debris. But before starting to dive into it, we're going to do the very traditional questions. What is your background?
Okay, yeah, good morning again. Yeah, so I started in Italy a long time ago with my degree already in aerospace engineering. I was particularly interested in space engineering and in particular in astrodynamics. That was really the topic for me that was the most interesting for me. And so after I finished my studies at the university, I decided to continue with the PhD. And space debris was actually a very interesting topic because it really based on astrodynamics, so how objects move in space and how we can model the effect of different forces on their trajectory. And also as a very practical application. So for me, that was a very interesting combination, and I decided to go in this direction. And I moved to the UK, to United Kingdom, for a PhD. And I stayed there for some years, working also on some additional topics like planetary protection. But everything related, let's say, to trajectories and how we can model them. And after that, I moved to Germany. First, I worked at OHB, so a company in the north of Germany, in Bremen, where I was working as a mission analysis engineer. And then I moved to Darmstadt, where I joined the Space Debris Office of the European Space Agency as a consultant. And there basically is where I've been working in all these almost, I think, 4 years and a half, working on space debris and specifically on the topic of mitigation. And yes, what is the current situation of space debris? What can we do in terms of guidelines, and also what can we do to ensure a more sustainable use of space?
Well, that's a very rich background that you have in this very specific topic, and that's why I'm very glad to have you today. I remember we met at the 2019 Space Debris Conference from ESA at Darmstadt, and I was quite impressed by your presentation back in the day. So again, thank you again so much for being here today. And first question that sounds basic, but I think it's very important to raise awareness on this topic. So, what are actually space debris? What are we talking about?
Yeah. So let's say the definition is that space debris is all the non-functional objects that are in orbit around the Earth or re-entering towards the Earth. As such, we talk about very different kind of objects. So you can have large spent satellites or rocket bodies. So for example, satellites that are no longer working, but they are still in orbit. Or you can go down to smaller objects, for example, fragments that have been generated by more than 600 fragmentations that happened in space. Fragmentation means either explosion or collisions. And also you can have objects that have been intentionally released during operation and left in orbit. So you have a very different, it's a variety of objects in space. And let's say currently, according to what we have we can see in the catalogs, there are more than 30,000 objects. And as I say, these are the ones that are cataloged. So this means that are large enough that we can observe them regularly, and we can predict their trajectories, and so we can keep a catalog of these objects. And it's estimated that there is instead a much larger population of smaller objects between 1 centimeter and 10 centimeters, which let's say count around 1 million of objects. And these objects are what they are usually called little non-trackable objects, as they are too small to be tracked from ground, but already large enough to be able to destroy a spacecraft in case of collision. And there are even smaller objects, of course, and then the population numbers are even larger. But in this case, usually, let's say this is possible to shield the spacecraft so that we can, let's say, limit the damage that these smaller objects can do on our mission. So this is a bit what is space debris.
All right. So, in a nutshell, I understand that is really created by the space exploration by mankind, and that's something that was quite amplified with the space race and all the debris from the rockets, satellites, etc. But one question would be: are we still producing space debris despite the technological advancement and the awareness about the topic?
Yes, because of several reasons. So, for example, as I said, one of the important sources of space debris are these fragmentation events that happened in the past, but actually they are still happening now. And at the European Space Agency, the Space Debris Office produces a report every year where we keep track of the status of the environment, and we present different statistics on what's going on in space related to space debris. And there, for example, we track the number of fragmentations per year. And if we look at the numbers, if we look at the statistics, we see that still on average we have around 12 fragmentations per year. And this number is not improving over time. So we still observe these fragmentations. Of course, in some cases, these fragmentations may be related to objects that have been launched in the past, so where, as you also already mentioned, certain technologies to avoid this kind of events were not available. But still, so there's a reason why we still nowadays observe the production of new objects. Another important point is the fact that also satellites and rocket bodies that arrive to the end of their missions or their lifetime, according to the existing guideline, should be disposed. So they should leave the operational orbit where they have been working. But this, also, especially for satellites in a low Earth orbit, is still something that is not done as often as maybe what we community, let's say, we wished for. And so also that contributes to an accumulation of mass of inactive objects in orbit that result in the increase of space debris.
Okay, so what's interesting to note from what you say is that there is the production of space debris because of space missions, but there is also a production of space debris from existing space debris, like some sort of, as you mentioned, fragmentation. So based on this situation, can we say that there is an emergency? So
I'm not sure if we can use the word emergency, but I maybe want to share with you an exercise that we performed also in this report that I just mentioned. What we try to do is to simulate what would happen in the space debris environment if we would extrapolate our current behavior in the long term. And here I need to make some, let's say, observations. First of all, is that why do we do this? Is because space debris is a bit, you can look at it a bit similarly to other issues like climate change. It's something that we really understand the impact of the actions on the long term. And that's why we tend to use simulations over 100 or 200 years to really understand how the evolution would look like. And when I say extrapolation, I mean that, for example, if I consider the kind of launch traffic that we observe now, but also the level of application of space debris mitigation guidelines, and for example, how many fragmentation we observe, how many objects are properly disposed at the end of their lifetime, etc. So if we do this exercise, actually what we observe is that we we predict a very important increase in the population over these 100 to 200 years, which, let's say, it's really, we think it's not compatible with safe operation in the future. So, in other words, we see that if we continue operating like we are doing now, in the future, we will make it very difficult for future generations to have access to space like we are doing now. So this is the current situation.
All right. So in this regard, what can we actually do to prevent the creation of new space debris?
So there are several aspects depending on these different sources that I mentioned before. And the first one, as I said, is these fragmentation events. And especially, for example, if we focus on the aspect of the explosions, you already mentioned that there is technology available now that was not available in the past. And there have been several studies, for example, from the Clean Space office in ESA, and also similarly at NASA, where they look at the development of technologies that can help passivating a system at the end of life. Passivating means that we make sure, for example, that all the fuel that is still in the spacecraft is vented at the end of the mission to minimize the risk of explosion in the future. So this is a first very important step that we could take, because as I mentioned, so we still observe these 12 fragmentations per year, and so if we would be able to bring the number to zero, then in this extrapolation exercise that I just mentioned, we will already be able to almost halve the number of predicted space debris objects at the end of the simulation, so in the 200 years time frame. Then something else that can be done is, of course, to improve our compliance to what is called post-mission disposal. So the fact that once that the emission is finished, the slot where it's operating should be freed, made available for other missions. And in low Earth orbit, so up to 2,000 kilometers, this means performing a re-entry if you are not already operating at an altitude that allows the spacecraft to come back within 25 years. And we see, as I said before, that this is still done only, let's say, roughly 40% of the time for the satellites that have reached end of life in the last decade. So already improving these numbers could be really, really, really beneficial. And actually, what is important here to mention is that we already observe in this recent year an improvement in these numbers, especially, for example, if we look at the operation of rocket bodies, so the launchers that are used in low Earth orbit. We see that in the beginning of the year 2000, only 20% of these objects were actually disposed, and now we are going towards a higher value of 80% and really increased adoption of controlled re-entry, so really minimizing the time that these objects are left in orbit. So let's say there is a shift in operations, and we know that in the geostationary orbit we also observe a very good performance in this field for the post-mission disposal. So things are, let's say, there could be room to be a bit optimistic in this regard. Then there are other aspects that are more related to, let's say, maybe also the more short-term effect of the presence of space debris, which is, for example, collision avoidance. Here, what is important to mention is that because of how the use of space has changed in the last years, we really are observing an important evolution also in the operation of collision avoidance. So, for example, if I think about our the fleet of ESA, so for which we provide collision avoidance service, we see that there is an increasing share of conjunctions with other satellites, especially at the certain altitudes. So we need to avoid active satellites instead of space debris, and this has really an impact in the operations. And we are still in the process of understanding how to handle this, how to make it more automated. And in this regard, what is important is to foster collaboration among different operators. So, for example, sharing the trajectories of the satellites, sharing planned maneuvers, and also really, let's say, share also the concept behind for example, what are reaction thresholds or the procedures, etc., in order to create a common understanding on how the risk is perceived, how different operators act on this risk. And this is important because, again, we want to avoid collisions between objects. And as I said, this is an evolving topic because, of course, we are still at a phase where there are not really rules of the road. So if two active spacecraft have a conjunction, we cannot say who of the two should maneuver first. So it's an evolving, really dynamic process at the moment. And of course, a last possible point is the use of active debris removal. And I mentioned this because in this same experiment that I mentioned before, where we extrapolated the behavior over the long term, what we also did was to do a simulation where we stop all the launches from 2021. And what we see is that even if we would stop all space activity, still the population of space debris would increase over time because of the collision and interaction between the objects that are already in orbit. So, of course, also this is an option to remove some of the mass there is of the spacecraft that is already in orbit. But of course, what is always important to stress and to keep in mind is that active debris removal really works when also all the other measures that I mentioned before, so the passivation, the disposal, are also implemented. So it's we have different handles, and we should, let's say, take advantage of all of them.
On the more practical side, one question I wanted to ask you, since you're a specialist of this topic, if you take, for instance, a new space initiative, a new space venture, what would be your advice for these people to have this sort of sustainable approach in their launch campaign, in their space missions? For
new space missions, for example, if we start from, let's start from small missions first. What we observe is that, so small missions, I mean, for example, CubeSat and this kind of satellites. What we observe is that, for example, last year, for the first time, we had more what we call ride shares. So launches where multiple payloads multiple satellites are delivered at the same time that launches where a single satellite is put into orbit. So this is really something, again, that is evolving. And what is increasing, what is happening is that so you have these rideshare launches where you have many satellites inserted into orbit at the same time. And this can really pose a challenge to space surveillance system to distinguish the different satellites. And this really can have negative consequences, both for the satellite operators, because imagine, for example, that you are not able to establish communication and to initiate some time critical operations, but also for the other operators, because, for example, in case there is a conjunction, you don't know who is your interface. So, for example, here, what can be done by these new actors is to improve the communication and the data sharing between operators with the space surveillance networks. And there are also, again, technical solutions that can be adopted, for example, like markers, to facilitate this identification process. So this is just one of examples. Then, again, if we stay in the realm of the the small missions, there is the indication, let's say, that if you don't have propulsion capabilities, then or also if you are testing some very innovative technical solutions, then it is advised to do this at a lower altitude, so that you limit the permanence in orbit. And also, for example, if there is a flow or something does not work as planned, the impact on the other operators and on the environment in general is limited. So this is for the, let's say, for the small missions part. If we look at larger let's say missions, for example, so large constellations and similar, there again there is a very important aspect of data sharing, coordination, so make the other operators aware of what are the choices that are performed. And also there, it's one very important aspect is also to understand which is the reliability of the spacecraft that are launched. This, especially when you are dealing with a large number of objects, it's very important to understand if we can commit, let's say, to a high level of reliability that results then in a high level of disposal. Level of compliance with disposal guidelines. So these are a bit some of the, let's say, the practical aspects that operators can look at. And as said, so the idea is that more coordination, and let's say it's for sure very, very welcome.
Well, that's very interesting what you mentioned about the idea of coordination, because space debris for me is really the segment as an attorney that shows the most bottom-up approach. Since we don't have any treaties that is actually dealing with the space debris issues, we see some accord, like for instance the Artemis Accord, that talking a little bit about this. You have national space laws, like for instance French space regulations that are dealing with this idea of remediation after decommissioning. So that's always interesting to notice how the industry and the stakeholders are taking care of this topic, and gradually that's come back up on top in order to have more solid regulation. Are you aware of any initiatives to actually regulate the segment, or do you have any idea about engineers or industrial stakeholders trying to implement like very, very forceful guidelines on this?
Yeah, so there has been in the past several of these initiatives. For example, the Space Safety Coalition, which is an organization or an association of different operators, have tried to collect guidelines that go a bit beyond what is currently encoded in the usual technical guidelines, like, for example, the one coming from the Interagency Space Debris Coordination Committee, so the IADC. So there has been this attempt, and also as personally from the Space Debris Office of the European Space Agency, we have been involved in another initiative that is called the Space Sustainability Rating, where so this was an initiative that was created by the World Economic Forum, and for which we have partnered with MIT and other stakeholders. And what we did was to prepare an indicator that rates the mission under several aspects that could affect its sustainability in terms of space debris. So looking, as I mentioned before, both at the impact on other operators, but also the impact on the environment in the long term. And in this initiative, we have developed and designed this rating, and now this has been passed to EPFL, so the École Polytechnique of Lausanne, which will operate this rating in the future. And again, the idea there is to, on one end, create awareness on the different choices that operators can make and how they affect their impact of the mission on the space debris environment, and also to recognize those operators that actually put in place better than required behavior. Because what we have observed in the past is that it's very difficult to hide in space. That's what we always say. So we know who are the bad actors. It's easy to know, let's say, who are the satellites that are not disposed, for example, at the end of their life. But the idea of the space sustainability rating is instead to shift a bit the perspective and to highlight who are the positive examples, and they can really be an inspiration, again, also for new actors, like we were briefly discussing before, to see actually which measures can be implemented, which one worked. And so this is a bit of the rationale behind this initiative as well. We are still, as I said in the beginning of this effort, so the rating will be fully operational from this year. So we will see how it will practically work in terms of incentive. But I think that there are several initiatives that are looking at this aspect, and also it's really clear how some of these new players that have come, especially in low Earth orbit, are really engaged and very responsive to the issue of space debris, and they want to, in general, show that they are committed to provide or implement technical solutions that will foster the sustainability of operations.
Well, Francesca, thank you so much for this briefing about this situation. I understand that, of course, there is a long-term emergency that we need to tackle now, and it's quite interesting to notice this joint effort of stakeholders with diverse background to trying to tackle and limit it and mitigate the impact of this crisis on the space industry. Thank you for your expertise, thank you for your intervention, and have a great day.
Thank you.
Si vous souhaitez obtenir de plus amples informations sur ce programme ou si vous avez besoin de services juridiques, vous pouvez contacter le Dr Numaisnar par courriel à l'adresse contact@numaisnar.com.
If you want more information about this program or need legal services, you can contact Dr. Numa Isnard via email at contact@numaisnard.com.